As we saw in the last video, the mesh render is very important for 3D elements, for these meshes, because this is used for drawing the cube that we have here right now, for example. So if it's disabled, we can't see the cube, but if we enable it appears in here. Okay, and there are lots of properties for this mesh render. We have the cast shadows property, so we can define if shadows are going to come out of this cube and to be drawn on other surfaces, for example. We of course have receive shadows if shadows of other elements are going to be drawn in this cube, and we have other things here, but the one that I want to talk about the most here is this materials property. Okay, so what's a material? Let's imagine a different case here. We have this cube, but we don't like this color. What if we want to turn it into red, for example? What do we need to do? If you go to the mesh render, you might have expected to have something like color. Okay, so you can just select the color and change to red, and then you can move forward with making your game. This doesn't happen because we need to do this with materials. Okay, of course it would be simple to have a red color picker in here, so you can just change the color of the cube, but it is important to understand this hierarchy. It is very important that we have this hierarchy because the materials can have much more details than just setting the color. Okay, so the responsibility of setting the color, among other things, is in the material. But here's the thing, we have a default material here. We can even expand it if we want. But notice that all the options that we have here are grayed out. Okay, no need to worry about what these options mean right now. Just see that everything is gray. Okay, we can't change anything. I can't change color, I can't change emission, detail mask, whatever I want here. This happens because this is the default material. Okay, as we made a very simple primitive 3D element, it needs to have at least one material. So Unity provides a default material here, okay, so we can't see the cube, otherwise it would be probably a pink color, okay, because that's default on some GPUs. So what if we want to change the color of the cube? To do this, we need to make our own material. So to do this, we're going to the Assets folder in the project window. We're going to right click, select Create, and then we're going to choose Material. Okay, and you notice that you can, in the beginning, you can, well, set the material's name. So let's set this to cube material or test material, for example. The name doesn't matter right now. And now, if you look at the inspector, you're going to see that there are lots of details about this material. Okay, so notice that the inspector window not only works with game objects, but it also works with the things that we have in our assets folder. So you can see lots of things here, like rendering mode, what is going to be the color, if we have a normal or height map. If you work with 3D software, you should be familiar with all of these names in here. But we're going to keep things simple. Okay, we just want to change the color of our cube. So we're going to pick and click this white rectangle here to open the color picker, and we're going to choose red. And notice that when you choose whatever color, notice that these little sliders, they change because every color that we choose is a composition of 4 values. Okay, it's a composition of red, green, blue, and alpha. Okay, so RGBA. And well, if we choose red, the red component is 255, and the other ones are 0. If we choose blue, for example, if we choose the right tone, well, it's 0 for red, 0 for green, and full for blue. And all the other intermediate colors, okay, are going to be a combination of these other colors that we have here. Okay, you can even see how the sliders swap positions while we define the color that we want. And we also have alpha here. Okay, so anyway, let's choose red. And we have our cube here. Let's select it. To apply this material, we can do this in 2 ways. You could either drag this material and drop in the cube while we are in the scene window, or if we have the cube selected and we go to the inspector, in the materials property of the mesh render component, there is a default material here. Okay, so we just need to drag and drop our newly created material to be in this place. So I'm going to drag and drop here, and our cube is now red. Okay, and we can basically do whatever we want. But what if we want this red color to be transparent? Okay, if I come here to this material, I click red, and I change alpha. Notice that nothing happens while I'm changing alpha. Okay, if I change the color, the cube instantly updates to go to whatever color we want, but not the transparency. So what if we wanted to make a glass here, glass wall? So let's make another one. We're going to go to our hierarchy, right click, select 3D object, and then cube again. So we have cube 1. we're going to change the position to be 0 on X, 0 on Y, and -1 on Z. And to make this cube thin, we're going to change its scale in the depth axis. Instead of 1, we use 0.2. And we can change X. Okay, so to make this wall to be squared, X and Y need to have the same value. So we can use 3 on X and 3 on Y, for example. Okay, so this is completely covering our cube. Let's also rename this cube to glass wall. Okay, so the game object is saved, it's been renamed, and let's make a material for this glass wall. So in our project window, we right click, create, we're going to choose material. This is going to be glass wall material. And now let's start by applying the material here. Okay, so I'm just going to drag and drop here, making sure that the glass wall is selected. And now I'm going to change its color. Let's change it to blue, like this one. Okay. And what if we want to apply transparency? We're going to decrease the alpha value, but you need to tell the renderer, okay, the shader that we're using, that we want this to be transparent. Okay, so why do we need to do this? This is important because of performance. Okay, we need to be very sure of what we're doing if we want to apply transparency, because transparency is a heavy operation. Okay, it's heavy to render, to draw a scene with lots of transparent objects. So you need to specifically tell that you know what you're doing and you want to apply transparency. Otherwise, you just waste some pressure resources. So to do this, we just go to the rendering mode and we're going to change from opaque to transparent. And notice how it changed. Apparently it just became lighter, but if you look it against the cube, it's working like a transparent wall. Okay, we can even make it a little bit like this. We can change the scale on Z to be thinner, so 0.01 for example. It's a very thin sheet of glass that is now in front of our cube. Okay, and now that we have these two elements, what if we want to make a floor? Okay, we can just right click here, select 3D object, and there are two ways. We could use plane. Okay, so it's basically a thin piece of paper, okay, a very thin piece of plane. You can just position here. Let's change the position to be 0, 0, 0. Okay, actually Y, let's use -2, like this. And to change the color of the plane, we can just create another material here. This is going to be the floor material. I'm going to apply this floor material in here, and I'm going to change its color to let me think. I think a dark green should be interesting here. Okay, so you have a dark green plane, and if you want to make it bigger, we just have to change the scale on X to something like 20, on Z to 20. Okay, almost we can nearly not see where this plane ends. Okay, and you can now notice a few things. We can start seeing the shadows to be rendered in this game. Okay, so we have the cube right here, and the shadowing is being projected in this plane. Okay, you can even move it down here, and we're going to see how the shadows are being rendered. And we also have a shadow for the glass, but we can barely see it. Okay, and now that we are talking about lighting, let's get in more details about this in the next video. Alright, so let's talk about lights. Whenever you're playing in a console, okay, in an Xbox One or a PlayStation 4, or maybe you're playing in your computer, you can be sure lighting is a very, very expensive operation. Okay, imagine we have this lighting here. Now imagine it is drawing several rays. Okay, it's like it's shooting on several directions at the same time. And then each of these rays, they check if they hit something. And well, if they hit something, they're going to shade that something with a certain strength and also project a shadow in the floor. This is very expensive. So on the other hand, it's something that makes the game to be realistic, to be more beautiful, because well, lights exist and shadows exist. If you don't have a light in your game, it's going to be very, very odd. Okay, so let's simulate that. Okay, I just deactivate the light, and if I want to increase the light of the scene, a global lighting, I can just go to Window. I can open the lighting selection the option here, and in scene we can change the ambient intensity to a value we want. Okay, it looks weird. Okay, it's like it's old school lighting system, an old school 3D game. Okay, so it's just not very good. Okay, that's why we need to have a light enabled if you want to have something that is barely realistic. Okay, now notice that this directional light here, there is an interesting property. If we change the position of this light in whatever axis we want, notice that the intensity doesn't change and the shadows, they don't change. This happens because this is a directional light, so it pretty much works as the sun. Okay, it's so far away from the earth, it's so far away from the scene that it doesn't matter where it is standing. Okay, the projections is going to be, they're all going to be the same. Okay, what changes here is if we change the rotation of this light. Okay, so for example, if I select the rotating tool here in the top left, I go to my scene window and I start rotating the light. Notice how the shading changes. Okay, if I move the light different directions, the shadows are going to be in different places. Okay, and you notice that if I move the light like this, I can see a dark side for this cube. Okay, there is one side that this cube is well lit, and the other one it's a bit darker because that's pretty much the direction where the sun is hitting the cube. Okay, and you can even see in the floor that if I move the sun to a certain angle, we can barely see a metallic effect here, almost like the sun is setting. And you notice that in earlier versions of Unity, we can even see the sun in this default skybox. So, well, notice that we can change the sun position to whatever we want. Okay, this directional light position to whatever we want. But the thing that matters is the rotation here. Okay, it's like we are changing the sun. And if we rotate it like this, then the scene becomes completely dark. Okay, it's like we are in the night now. So, well, we can't see our game. Okay, so that's pretty much how the directional lights work. Imagine it's the sun. Okay, that's pretty much it for this directional light. But we also have other kinds of lights. Okay, the other one that is more common is spot. Okay, so it's going to work like this. It's well, it's a spotlight. It's going to be rendered in a certain direction. Okay, so let me try to position it on top of this cube, and just a little bit of rotation like this, and we can change things like the range of this light, so how far it gets, the angle, so how wide it's going to be, okay, and also the intensity, if it's going to be strong or not. So this spotlight is interesting to give some sort of, let me see, to feature an element in the game. Okay, so if we want to give attention to the cube and not the entire plane, we can just add a spotlight here that is going to be aiming at this cube. Okay, we can see it very clearly in this case. Okay, and we can also change the color. Okay, so if we want the spotlight to be something blue like this, okay, a bit mysterious, or if we want to add red to give a sense of danger, we can just use our creativity to change this color to something that is going to be interesting for us. Okay, so let's go back to the directional light, and the other one that we have here that we can use is point. Okay, now this is the simplest of them all. Okay, the point light is, well, basically a light bulb. Okay, so it's a point that is going to project light into all directions. Okay, and you can even see, if you go far away from this point light in the scene window, notice that there's a yellow sphere. This is the range of this point light. So you can decrease the range of it to make it, well, closer to the exact point where it is. And as we use with the other light, with the spotlight, we can change intensity as well. So we can make this strong, and it's going to look like this. Okay, this is, well, a spotlight. It's like a light bulb. And later we can change how strong or how weak the shadows are going to be. Okay, notice that if I use 1, we can see the shadow very well for this cube. But if we change it to 0, for example, the shadow completely disappears. So this is something that we can use to make this game as we want. Okay, and again, notice we are just experimenting here. We are trying different types of lights. We tried point, spot, we tried direction. Okay, there are several different things that you can do. You can just play around with these, change positions, change rotations, change scale of the objects that you have selected to achieve the effect that you want. Okay, so be curious and experiment a lot. another interesting feature of Unity is the usage of particle systems. So what are particle systems? They are systems that can easily add beautiful particles to your game. Okay, so to make one, we can just go to a hierarchy here, right click, and then we can select particle system. And when we have the particle system selected here, okay, let's change its position to something like 0, 0, 0. So it looks like this. And you notice that we can see, well, some white clouds getting out of the exact position where the particle system is, which is the origin of these arrows here. So we can move the particle system just like any other object that we want, okay, to any position that we want. So if we want to make it to be in the cube, we can just drag the particle system to be in the cube, okay, which takes us to another subject. Notice that the particle system here is at the position 0, 0, 0. But if we move it to the cube, okay, it's in the exact same place in the scene, but the position changed to 0, 1.50. It does that because this position that we see here is local, so it's relative to the parent, okay? Since the cube is in the position 0, minus 1.50, the particle system went to the opposite place in the vertical position, so its world position is the origin, okay? But if we want the particle system to come out to from wherever the cube is, we can just change it to 0. So you notice here that the particle is right in the middle. Okay, so the particle systems are kind of complex, okay, because there are so many settings to the particle system. If you take a quick look here by scrolling down, you're going to see that there are lots of settings here, and there are lots of other settings in here, okay, so it takes quite a while to take a look on all of these. So let's just look at the important ones. So first of all, notice that we have this particle effect menu here in the scene window, so at any time we can pause, we can stop the simulation, or just start the simulation again to see the particles coming out of the cube, okay, like this. It's a pretty wide area that we see here. And the duration is basically for how long this particle system is going to happen. Okay, so if we change it to 1, it's going to be a bit quicker, but well, let's leave it at 5. So the start delay is how much it's going to wait once the game starts so the particles start coming out. So if we change start delay to 3 and hit simulate, we're going to wait exactly 3 seconds until the first particles start coming out. Okay, so let's leave this as 1, just because. Okay, so the lifetime is how long each of the particles are going to be alive. Okay, how long it's going we are going to wait until they start disappearing. So if we change the lifetime to 1, notice that they are getting killed much earlier. Okay, they reach barely this height here and they start disappearing. But let's leave it that way. Okay, and speed is, well, as you might suspect. If you change this to a high number, they're going to move much faster than before. But if it's a low number, they're going to barely exit the cube. Okay, let's leave it at 3. And we have other things here, like we might change the rotation if we want. We can change the color. So, for example, if you click here and choose yellow, for example, we directly change the particle color. Okay, and something that is interesting is the gravity modifier. So this is what we want to do. Let's get this particle system and we're going to rotate it. I'm going to select the rotating tool. We're going to grab the green circle and we're going to make it like this. Okay. And if we apply the gravity modifier, if we use 1 here, notice that the particles are falling, just like physics is applied to them. Okay, and we can increase the speed to make them to be propelled a bit more backwards. Okay, so I think it gives an interesting effect. If we start tuning this to something like this, okay, let's use start speed as 6. We apply the gravity modifier, and if we make the cube move to the right, it's going to have an interesting effect. Okay, and there's something that is important here. Okay, notice that there's a property that is called simulation space, and it's called local in here. Okay, so if we move this particle system around, like I'm doing right now, notice that all the particles are following this game object. Okay, remember, we have this particle system game object, which contains a particle system component. If I move the game object, all of the particles are following. However, if we move the simulation space to world, apparently it is the same thing. Okay, and if we leave it local, it's going to be like this. If we leave it world, it's going to be like this. But if we use world and we move this, notice that not all the particles are following. Okay, it's like the particles are now independent of this game object. Okay, if, for example, if the game object is here, the particles that are going to appear when I put it here are independent from the other one. Okay, but if we use the local, it doesn't matter how quick I move, all of them are going to follow this game object. Okay, so we want to give this to use world here because we want to make an interesting effect soon enough. Okay, and later if you want, you can take more a better look on these other settings that we have here. So if we increase the rate, or if you decrease it, you're going to see lesser particles than before. We can use 8, for example, and you can change the shape of the area that is being used for throwing these particles. Okay, so you can make a cone that contains a very small angle or a wide angle like this. Well, it's just experiment. Okay, be curious, open these things, and start changing these properties. Okay. So, in the next video, now that we have this cube that contains a particle system inside it, let's make this cube move. The way we want to make this cube to move is going to be, we're going to make it fall. Okay, so if we move this cube up, we want it to be, to physics to be applied to this cube so it falls in this plane. Okay, notice that if we press the play button right now, the editor becomes a bit darker and, well, it loads a little bit, and we can see that these buttons, they became blue. Okay, that means that the scene is live. So what we see here is a live simulation of our game. So if we make this game to run on an Android device, or if we generate a desktop build, whatever build we can imagine, what we see here in this window is going to be what the players are going to see. Okay, so this is the actual simulation. But, well, the cube is not falling. Okay, why is this happening? This is happening because we need to specifically tell Unity that we want this cube to respect the laws of physics. And to do this, we need to change this a little bit. So in our hierarchy, we're going to select this cube, okay, here. And if you go to the inspector, we're going to see that we have a few components. We have transform, mesh filter, box collider, and mesh render. What we want to do here is add a new component. We're going to add a rigid body. To add a rigid body, we're going to go to this button here, add component. We click on it, and you notice there's going to be a little searching area, and we're going to search for rigid body, and then we click here, this rigid body, and you notice that there are some settings in here. So we have mass, drag, angular drag, use gravity. So all of these things that we see here, they are related to physics. Okay, this means that this is going to respect physics. The object is going to fall. If there's something in the way, well, it's going to hit these things and it's going to rotate. Okay, so all of these things are going to be considered. So by just adding this rigid body, if we press the play button, the cube basically falls, okay, to this place. And notice, however, that the particle system, it's a bit odd that it goes to the left. Okay, so we can just go to the particle system, and then let's change a few things here. So we're going to change its rotation to be, let me see, 90 on X, actually minus 90 on X, minus 90 on Y, and 90 on Z. Okay, this is going to work well. And, well, we can remove the delay, so we can set that to 0. So when the cube falls, well, all the particles are going to follow as well. Okay, and you might notice that if you come here and if you rotate this cube, okay, so if we go to this hierarchy here, select the cube and change its rotation on X to 45, Y to 45, and Z to something like 40, for example, and you press play, as the cube hits the floor, it starts kind of tumbling to the other sides, okay? And if we want to make this even more interesting, we can change the cube's position to somewhere higher, and we can add some other cubes in here. Okay, so this cube collides with the other ones. So for example, if I go here, select 3D object, and then, better yet, let's use a sphere. Okay, we have this sphere here. And if we want to make the cube to collide with this sphere, we can just position it right under this the cube like this. Okay, so we have this one here. We can press the play button. So the physics is simulated, the cube touches the sphere and now falls to the side. So we can do a little physical playing here. Okay, we can just reposition these spheres to other positions and kind of watch the cube to fall. Okay, and to duplicate these spheres that we're adding, we can just hit Ctrl D, Command D, or just right click and select duplicate. Okay, so you just position these things to whatever you want. Okay, so it's a very simple simulation. We can see physics being applied, the cube is falling and tumbling to other places, and we have a particle system. So it's a very, very basic simulation. Okay, so that's pretty much it for this video. And notice that when you set up a scene, you need to save it. Okay, notice that in our hierarchy, at the top of everything as we see here, the top of all of these game objects, we see that there is an untitled element here, because this is the actual scene. The scene contains all of the game objects, all of its hierarchy, it's right here. So it says untitled, and we have this asterisk. That means that this scene hasn't been saved. So to save it, we can just go to File, hit Save Scene, and give whatever name we want. So we can just call this, for example, game.unity. Okay, so in our assets folder, we now have a file called game.unity. Okay, so well, that's pretty much it for this simulation. Everything we did so far, it's been working with things that Unity already provided us. Okay, so we have the scene, we've added a cube, we've added a glass wall and changed the materials to change the transparency and color. We've added some spheres and particle systems, okay, and once we hit the play button, we can get the full simulation that we wanted to achieve. But the thing is, what we have here can be easily extended if we try to find new assets. Okay, now that we have this working logic, we can swap this for something beautiful. So instead of having this green field in here that is too simple and then having these flying spheres, maybe we can swap with other assets. You have two options. You might try to design these assets by yourself, or you can go to Unity's Asset Store. That can be accessed in Unity Editor by clicking on Window and going to the Asset Store or hitting Command 9, or you can just go straight to the website. Now, the good thing about the Asset Store is that this is an entire ecosystem of plugins and asset packages that you can just buy and add to your project. And well, in general, we don't have to reinvent the wheel. Okay, so if someone already made a first-person shooter pack, for example, when you want to be quick, you want to focus on making the game and getting out there, you can just go to the asset store and purchase that. Or if you want a pack of skyboxes, if maybe you want a football stadium or the Coliseum, for example, you can just come here, browse for the files, and well, search for everything you need. Still, it is important for us to understand how it works on bare bones, so how physics work, how cubes work, so you can later understand what's happening behind the scenes. So if you go to the asset store, you're going to see that there are lots of categories in here. So we can go straight to 3D models or animations. We can search for complete projects that we can later extend. Okay, there's scripts, services, shaders. There are basically lots of things in here. And almost every day there's a sale going on. So we can find some very nice prices in here. If you go to 3D models, for example, notice that there are lots of filters in here that you can select. So for instance, if you want only free 3D models, you can just mark this and you're going to see lots of options in here. There are trees, there are entire cities, there's a male character, a robot character, cars. So you can just go here. Okay, of course you need an account in Unity. Just download that, import to your project. It's going to be here in the assets folder, and you can just add that to your game. So it's important. From time to time, take a look on the asset store. There might be something that can help you on making your game. So you can focus on making the actual game, on developing the fun for the players. Okay, so that's the last tip for this video. I hope you enjoyed this tutorial, and I hope to see you next time.